Here are warm-ups for today. We are doing a review of chapter 6. So let's look at this first one. Write using an exponent. How could I write this one using an exponent? Who can tell me, Rocco?
Wait, hold up. Oh.
Yes, Rocco, it's 13 to the power of 5. We know that because we have 5 number 13s. 1, 2, 3, 4, 5. This tells us to do 5. Is this the same as 13 to the 5th? Is that the same as 13 times 5?
No.
Is 13 to the 5th the same as 13 times 5?
No.
No, it is not. Those are completely different things, and I can prove it to you. Let's look at this one. Let's look at 4 squared and 4 times 2. What is 4 squared? Who can tell me, Lucy? 16. What is 4 times 2, Ben? 8. Which means that these two are not equal.
No, they're not.
So, let's look at the next one. Write in long form. That's the expanded form. That's essentially without our exponent. How could I write 0.5 cubed in long form? Miles.
Right, 0.5 times 0.5 times 0.5.
Excellent. Now, when we're doing this, are we adding them all together? Are we adding or multiplying?
Multiply.
We're multiplying. A lot of on your homeworks, I saw you guys add these and you would get like 1.5 or you'd do something silly. It is multiplication. And you could multiply it with decimals or you could make it easier and into fractions. What is 0.5 as a fraction? What is 0.5 as a fraction? Oswaldo? 1/2. So it'd be 1/2 times 1/2 times 1/2. We know we multiply across, so then we would get 1/8. That's what our answer would be. You could either do it with decimals or with fractions. You'll get the same answer. You will, I promise. So I believe that this answer, if we did it here, would be 0.125. Yes, it's going to be 0.125. Same thing. Same exact thing. Now, let's look at this one. Solve this problem. How many of you guys had trouble solving this problem? We see just a couple hands up. That's okay that we see some hands up. Okay, so let's look at this problem together. So, what are we always going to follow? What's the rule of what we follow, Adriana? We follow Pemdas. So, let's look at this problem then. 27 divided by, in parentheses, 5 minus 2 squared times 5 minus 12. So, let's look at this together. What is our first step? Which part of this problem is our first step, Lucy? The parentheses. So we have to solve the parentheses. 5 minus 2, show me your fingers. It is 3. So now we have 27 divided by 3 squared times 5 minus 12. So we did our parentheses. And that squared is applying directly to that parentheses. Everything in the parentheses, it is applied to. Everything in the parentheses it is applied to. So, now when we look at this first part right here, it says in parentheses 5 minus 2 squared. Several people ask me, does the squared just apply to the 2? Do we do the square first? What do we do? The answer is we have to solve what's in the parentheses, and because the 2 is touching the parentheses, it applies to everything in the parentheses. So, for example, if I had in my parentheses something like this, x minus 2 squared, I would have to square it, but we don't know how to do that yet. Well, it's not just squaring it for each of them. It is not just that. When we are doing it, if we had x minus 2 squared, that's the same as having x minus 2 twice. You remember how we did that for the earlier problem? So that would be, again, x minus 2. Now, I'm not going to have you do necessarily things like this because it's a little bit of higher math, but it would be distributive property the same way. We distribute this one, we distribute this one. So we would get, if we distributed, we would get x times x, x squared, x times -2, minus 2x, negative 2 times x, minus 2x, negative 2 times -2 plus 4. Then we would combine like terms. This is a little bit further. We're doing that, but we're not working on that kind of problem right now. So here's our steps that we've gotten down to. We have so far solved for the parentheses. What comes next in our steps, Anita? Exponent. So what do we do to solve the exponent? How do I solve this exponent, Lucy? Yeah, so we do 3 to the second power, 3 to the power 2, 3 squared, which is 3 times 3. 3 times 3 is 9. So we get this to be now 27 divided by 9 times 5 minus 12. Excellent. Now is it time for multiplication? Because I see the multiplication right here. Do we do that next? Because that's what it says in Pemdas. It has multiplication. So raise your hand if you think yes, that we do multiplication right now. Raise your hand if you think no, we do not. Correct, we do not. Why do we not just do the multiplication even though it comes first in that statement? I want Rafi. Exactly. Multiplication, division are the same. Addition and subtraction are the same. When we do this, it is pertinent. It is very important. We go left to right. So what is 27 divided by 9? 27 divided by 9. Let me see. Daniel. We get 3. Then we have times 5 minus 12. What's 3 times 5? 3 times 5. Emerson. We got 15 minus 12. And then what do we get as our answer, Adriana? 3. If you did not do these steps correctly, you will have messed up big time. We always have to remember how to do PEMDAS. We apply the multiplication and division in reverse order just because it's left to right. Then we did no addition, but we did subtraction. So that's how we follow along with this. To explain how multiplication and division are the same thing, just inverses of each other, let's look at this one. I want 7 times 2. What is 7 times 2? 14. Now, we are going to do the inverse. What is the inverse? It's keep, change, flip when we do division. So what is it, Liam? It'd be 7 divided by, because we did the keep, we did the change, and then the flip becomes 1 over 2, right? So that's how we do it. 7 divided by 1/2, once again, is the same here, because once again, we would keep, change, flip it back. Do you see how that makes sense? We're just keep, change, flipping for the both of them. Your answer is gonna be 14, no matter which way you go about it. So, now, the next problem. Solve c squared plus a when c is 9 and a is 1/2. So we have c squared plus a. C is equal to 9 and a is equal to 1/2. So what do we do? What kind of problems do I call these again? Who can tell me? I call these certain things because it helps me remember. What do I call them?
Oh, isn't it like KCF?
That is for the keep, change, flip, so perfect, but not what I call these problems, the plug and play problems. I call them that because what we're doing is we're just plugging the numbers in. So we plug in 9 for C. We get 9 squared. Then we plug in 1/2 for A. What is 9 squared? Who can tell me by raising their hand? 9 squared, Michelle? We get 81 plus 1/2. What is 81 plus 1/2, Hannah? 81 and 1/2. Exactly. I call these plug and play because all we're doing is we're plugging in numbers and then solving. Then this next one, I want you to write this expression. So here we have 4 points fewer than what the Panthers scored. So many of you had problems with this. So we're going to look at this problem again together. What is one of our key terms? What is one of our key terms here, Fernando? Yeah, we see the word fewer, which means subtraction. What do we see next to that word, Daniel? Than. What does than indicate? Rafi? Than does not indicate subtraction, but you're close. What does than indicate, Adriana? Not addition. Another great guess. Liam? Not division. Another great guess, but we're so close. We're getting there. Let's see, Romario. Not multiplication. We've listed all of our operations so far. What is it, Lucy? Yes, that the subtraction comes after the variable. When we see the word than, we know that it's going to be minus whatever our number is. So it's 4 points fewer than, which means minus 4. Something minus 4. Something minus 4. How much did the Panthers score? Do we know? So we don't know how much the Panthers score, so it is our unknown. So then it becomes P minus 4. Let's say I wrote 4 points fewer than 1/3 of what the Panthers scored. Now we have another key word. What is that word? Yeah, we see that word of, which means multiplication. So if we were to write this out, 4 points fewer than minus 4, 1/3 of, 1/3 times, and then our unknown, Panthers. So what we're going to do is we're going to match them. Write this on your paper. Write it on your paper like this so that you're able to put the answers below. Now, each property, I made 2 examples of answers. Each property has 2 examples of answers. So you need to find which is which and put them in the proper box. Associative properties. Which one of these? There's 2 examples. Which 2 are going to be an associative property? Tell me one of them, Lucy. Excellent. So that's one example. A plus, in parentheses, B plus C is equal to, in parentheses, A plus B plus C. Those are the same thing. Could I do it if it was subtraction? No, you cannot. Properties only work for addition and multiplication. That is it. What is our other one, Anita? Yes, A times, in parentheses, B times C is equal to, in parentheses, A times B times C. Notice that those are ones that have parentheses with it. It's kind of helpful when you see that because you know that that's associative property. It doesn't always apply, but we know that if we're looking for a property and it has parentheses, we can eliminate the commutative and identity. Next one, commutative. Commutative. Let's see. Ben, give me one example. A times B equals B times A. Correct. That's cumulative because we're still going to get the same answer. What if it was... Well, what if... Commutative, apparently. I still can't say it right. What's the other one that is commutative property? What's the other one, Michelle? So it is A plus B is equal to B plus A. Now we've got distributive. We have distributive. Give me an example of the distributive property. Adriana. Okay, never mind for Adriana. Give me an example of distributive property, Hannah. Hannah is correct. Distributive would be the 8 plus 16 is equal to 8 in parentheses 1 plus 2. How do we know that that's distributive? How do we know it's distributive? Do we know how we know it, or are we just taking guesses?
No, I just rolled out every single one.
You ruled them out. That's a good idea. The reason that they're distributive is because if I distributed that 8, if I multiplied that in, what's 8 times 1? 8. What's 8 times 2? Notice that that's 8 plus 16. So when I distribute this 8 and multiply it times each of those, I get that other answer. What else is the distributive property? Adriana.
7 parentheses x power 2 minus 3 minus 7x minus 21.
Excellent. Once again, it's 7 times in parentheses x squared minus 3 is equal to 7x squared minus 21. We're following that same formula where we multiply it into each of them. 7 times x squared is 7x squared. 7 times negative 3 is negative 21. Now, yes, these are the only two left, but give me an example of the identity problem, or give me, what is the identity one? What is the identity one? Romario. Yeah, A times 1 equals A. In this case, when we do this, anything times 1 is itself. We know that. Anything times 1 is itself. If I had Rocco come up here and I multiplied him times 1, I'm only going to have 1 Rocco. Now, lastly, what is the other one that is the identity property? The other one that's identity, Alinza. It's going to be A plus 0 equals A. Because look again, anything plus 0 is just itself. So we know that those two work as the identity because they both end up with that original value, either plus 0 or times 1. That's what's important. So now what I want you to do is, for the first problem, combine the like terms. For the second problem, factor it. And for the third one, I want you to identify the terms, coefficients, and constants of this problem. First things first, following PEMDAS, we do the parentheses. So is there anything we can combine in the parentheses? Are there any like terms in the parentheses? What are the like terms, Romario? The what? Who else can tell me what the like terms are? Jenna. Perfect. We can combine those two because they both have x's. Always make sure you circle the operation in front of it. It is very different if I did not circle the operation. You always have to circle the operation. What is 7x minus 2x? Exactly, Liam. We get 5x. Is there anything I can combine y with? The y plus 5y? Anything? No. It just stays the same. Is there anything I can combine the 3 with? No. So it just stays the same. Then we've got a 4 on the outside. In this case, now we can distribute it. 4 times 5x. What is 4 times 5x? 4 times 5x. Fernando. 20x. What is 4 times 5y? Now everyone should know it because Fernando gave us a great hint. What's 4 times 5y? 4 times 5y, Miles. 20y. And then what's 4 times 3? Hannah. 12. Exactly. Can I combine anything here? No. This is my answer. I can't combine it. Don't get thrown off. When I'm asking you to write expressions or simplify, you're not going to have an answer unless I tell you what the variables mean. Do not think that you are going to get a number as an answer unless I say x equals or y equals. Otherwise, you're going to get an expression. Now, the next way to do the problem is to simply multiply through. As Adriana did, she multiplied before she did the like terms. And that's totally okay too with the distributive property. So, what is 4 times 7x, Adriana? We got 28x. What is 4 times 5y? What is 4 times 5y, Matthew? Miles, what is 4 times 5y?
20y.
Not hard, exactly. It's 20y. What is 4 times positive 3? What is 4 times positive 3? Adriana? 12. And then what is 4 times negative 2x? 4 times negative 2x. What is it, Adriana? 8. Not 8. We're super close. What is it, Daniel?
6.
Not 6. What is it, Oswaldo? What? Negative 8x. Exactly. We just multiplied this across. We do not know what our x's and y's are yet. Now we combine like terms. We combine like terms. What are the like terms in this problem? Yeah, so Romario said it correctly. 28x and that negative 8x. You have to put that operation. We combine those. What's 28x minus 8x, Michelle? Yeah, 20x. That 20y, can I combine that with anything? No. Plus 20y. And that 12, can I combine that with anything? No, so it's 12. Look at those two different ways you can solve it. You could either solve in the parentheses first or distribute first. This only works with the distributive property when we're following the rules of the distributive property. So, I want you to write this one in long form and then solve it. And then I want you to solve problem number 26. For 26, you need to write an expression and then find the total number, okay? There's two parts to this problem. We write this in expanded form. How many number 3s? How many of my factor am I gonna have? How many number 3s, Hannah? 7. It becomes 3 times 3 times 3 times 3 times 3 times 3 times 3. Now, like I said, I like to group it to make it easier. Here's 3 times 3 times 3. Here's another 3 times 3 times 3, and then times 3. What's 3 times 3 times 3? What's 27? So this is 27, this is 27, and this is 3. So to multiply it easier, all you have to do is now multiply these three numbers. 27 times 27 times 3. Does anybody have an answer for this? Does anybody have an answer for this? Matthew says the answer is 2,187. He said 2,187, which is correct. So, Addison is making caramel apples. She has 2.5 bags of apples. One full bag has 8 apples, and each apple weighs 5 ounces. So first of all, if she has 2.5 bags of apples, and each bag holds 8 apples, then how many apples do I have in total? Lucy? I have 20. So all we're doing there is we're going to be multiplying that 2.5 by 8. Why did I multiply that 2.5 by 8? Why did I do that, Anita? Exactly. 2.5 bags, and in each bag is 8. Perfect. We have 8 apples in each bag. We have 2.5 bags, so we multiply. Then each apple weighs 5 ounces. Now what do I do if each apple weighs 5 ounces? Hannah?
You would put that in parentheses and then put
Yeah, we could just do times 5. Excellent. So 2.5 times 8, we got 20 times 5. What's 20 times 5? What is 20 times 5? Liam. It is 100. So what we get here when we multiply, we get 100 ounces. You need to make sure that you have both parts. Otherwise, you will only get half credit. You need to write that expression and find the total number of ounces. You need both parts. I don't want just the answer. I don't want just the expression. You read it and you do both. Okay, now I want you to solve for this. So this is the first one. Solve for 14x when x is equal to 1/2. Solve for 14x when x equals 1/2. What is the first step that we do in this problem? What do? I want to see things. Miles, what did you do?
But for the problem,
Yes.
I just did it like first I made the fraction a decimal.
Perfect. So you made a fraction a decimal. You don't have to do that. You can keep it as a fraction or you can do it as a decimal. Either way works as long as you make it the correct decimal to fraction. What did you do, Ben?
I just multiplied 14 times 1/2
How'd you know to put the 1/2 there?
because it says x equals 1/2.
X equals 1/2. Yes. So I'm going to show you 2 examples and you're going to tell me which is correct. Is it going to be 14 and 1/2 or is it going to be 14 times 1/2? Which is correct? The top or the bottom, Rafi? Is it 14 and 1/2 or is it 14 times 1/2? Yes, so we're multiplying here. Remember, when things touch, we multiply. Now what we can do, we set it up. When we multiply, we make them both into What do we make them both into when we multiply, Lucy? Fractions. What is 14 as a fraction? Who can tell me what 14 as a fraction is? Ooh, I'm getting lots of hands. I want to see even more. What is 14 as a fraction? In fact, what I want to see, show me on your fingers. 14 is, what is it going to be at the bottom? What is it at the bottom? It is 1. Anything can be a fraction over 1. What can I do next? Can I do something next? What do I do, Nathan? I cross cancel. I can cross cancel that 14 and 2 because 1 and 1 are already done. When I cross cancel that 14 and the 2, what do I get out of it? What does that 14 become? What does it become, Oswaldo? 7. What does that 2 become? What does that 2 become, Romario? 1. So now we multiply. How do we multiply? Across or cross? How do we multiply? Across or cross? What do I do, Fernando? Across. So I've got 7 times 1 over 1 times 1, which means my answer is 7. Now, we only have a little bit of time, so we're going to look at these 3. Are these equivalent? Is 8 divided by 2 the same as 2 divided by 8? What do we think? Raise your hands if you think yes. Raise your hand if you say no. Exactly. This is dealing with one of our properties, but the properties only work with addition and multiplication, just like we said earlier. So these are not equal. What about the second one? Are these 2 equal? Raise your hand if they are equal. Raise your hand if they are not equal. Correct, they are equal. What method did I use? What property did I use to solve this, Oswaldo? Distribution, exactly. And then last one. Are these equal or are they not? And there might be a trick. I want to see what you guys think. Are they equal or are they not? Lucy? Yeah, she's exactly correct. So they can only be equal if y and x are the same for both. So we would need to have y equals 2 and x equals 2. If I have anything else, they're not going to be equal. Just like at that other day when we did our rock, paper, scissors, these ones are sometimes equal. Sometimes equal. Now, we're going to get to these tomorrow, but what I want from you to do for homework is I want you guys, for homework, you find 2 problems from the book that you struggle with so that we're able to go over it on the last day of our review, which is Friday. Test is on Monday, the 27th. Problem number 21. Moesha's music library has 17 more than 2 times the number of songs than Damien's music library. Okay, what's the first important word, Anita? More. It says more than, we see that, but it means that when we see than, it means it goes after. However, with addition, it doesn't have to because of what property, Ben? Yeah, the commutative property. So we don't need to do anything there. More means addition. And if you didn't know that, then that's sad. What's our next key word? What's our next key word, Lucy? Times. Exactly. We see that word times, which means multiply. And we see that 2, which is indicating how much we are multiplying it by. Now, what is our unknown in this problem? What is the unknown, Miles? Yeah, we see than Damien's music library. So we go sentence by sentence. Damien's music library is the unknown. So we're going to represent it by D. Next sentence. Define a variable and write the expression to represent the number of songs in Moesha's library. Hey, look at that. We already defined our variable because we know that our variable is our unknown, which is Damien's music library. So since we've defined our unknown and we've found our keywords, we can begin this problem. So 17 more. That means 17 plus, right? And then 2 times. Then we've got 2 times. And it's the songs in his library, which is our unknown, D. How many of you got a formula that looked like this? How many of you got a formula that looked like this? So Elsie brought up, what if we wrote it like this? 2 D plus 17. Yeah, that's correct. Even this one, are you ready? 2D plus 17. We could even have 17 plus 2D. All of these are different ways to write the same thing. They are all correct. Here's how you test it, by the way. Remember how I said make up a number? If you're unsure, there you actually give us a number. But you make it up and you see, oh, do these formulas match? Oh, does it match up with that? So now what we're going to do, we'll use just this first formula, not because it's better, but it's just the first one here. Now we have figured out how much Damien's music library has. How much does Damien's music have? How much does it have, Malia? 5 songs. So all I do is I do my plug and play. I plug it in for D. I now get 17 plus 2 times 5. So what am I going to do here? Am I going to make it 19 times 5 or am I going to make it 17 times 10? Which one am I going to do? 19 times 5 or 17 times 10? 19 times 5, 17 times 10. Hannah. 17 times 10. Can you explain why we're going to be doing 17 times 10?
Because you can't, following Pemdas, you can't do addition first.
Exactly. Following Pemdas, we can't do the addition first. The mistake in this problem is that we added before we multiplied. You have to follow Pemdas. So the correct one is this, which, by the way, means that our answer happens to be, I was actually wrong, it's plus, not times 5, but thank you for catching me, Gloria, because I was looking at this and it seemed a bit unreasonable. Actually, that's another good tip. I was looking at this problem and I was thinking, this doesn't make sense. He has 5 songs and she has 170. That doesn't make much sense. That's how I realized my error. So we get 17 plus 10. 17 plus 10, what is that? Who can tell me, Jaden?
I got 95.
What is 17 plus 10, Matthew? Perfect, Matthew. That's equal to 27. So in order to get this problem right, you need both of these parts because it tells us to write an expression. If you only give me the answer, if you just write 27, you're not going to be correct. You have to show your work. You have to do that problem. So let's look at our next problem. We'll do the next one. Sierra has 3 more than 1/2 as many purses as Aisha. Let's look at that first sentence and highlight our important words. What's our first important word, Ben?
3 more?
Yeah, we've got more, and we know that it's going to be 3 more. More means plus. We see that more than, but once again, based on the commutative property, the than is not important. Now, what's our second important word in this one? What's our second, Fernando? Yeah, we have half, right? When we're doing half, there's 2 ways we can do this. Who knows how we can do half? Give me one of the ways that we can find half, Lucy. Yeah, one of the ways to do half is divide it by 2. What's the other way to do half, Hannah? Multiply it by 1/2. Yet again, these are the exact same thing. These are the exact same thing. You can't divide by 1/2 and you can't multiply by 2. To get 1/2, you have to divide it into 2 parts or multiply it by half, whichever one is easier for you to remember. So we've got our thing. We've got more than, 3 more than, and 1/2. So I'm going to start the problem. I've got 3 more, and then I have 1/2 times, and what don't we know? What is our unknown in this problem, Michelle? Exactly. It's the purses that Aisha has. That's our unknown. So I'm going to make it in A. That's me defining my variable. So I plug it in. 1/2 as many as Aisha has. So this is what our formula looks like. 3 plus 1/2 A. So we need this part of our equation. Like I said, we need this in order to continue. We can't leave that out. Then we do plug and play. How many purses does Aisha have? How many purses does Aisha have, Nathan?
12.
She has 12. So we plug in 12 for A. We're getting 3 plus 1/2 times 12. So, am I going to get 3.5 times 12? No, we can't do the addition first. We cannot. So, what's 1/2 times 12? What's 1/2 times 12? I want to see a lot more hands up. Let's see, Miles. It is 6. Again, we did the dividing by 2. It's the same thing. So we figured that out. We have 6. And then we do our final step, 3 plus 6. What is 3 plus 6 equal to? What is it, Daniel? 9. So Sierra has 9 purses. Personally, I think it's an unreasonable number of purses to have. But that's just my own opinion. I want you to go to page 479. And we're going to work on 19 to 22 first. 19 to 22 first. On the board, just so you don't have to flip back and forth, I'm putting up the properties. So I put up the properties on the board. You can just look up and use it to solve. Ben asked a good question. He says, does this work with division? Who can tell me? Oh, I apologize. That's Daniel who asked. Who can tell me, does it work with division? Raise your hand and let me know. Tell me. Ben? It does not work with division. Does it work with subtraction? It also doesn't work with subtraction. These properties only work when they are added or multiplied. When they are added or multiplied. When they are added or multiplied. Only addition and multiplication do our properties work. Not with division and not with subtraction. So let's look at this first problem, number 19. Does this work? Does this expression, are they equivalent? And if they are equivalent, why are they equivalent? So, thumbs up if they are equivalent.
Wait, which one?
For number 19. Thumbs up if 19 is equivalent. Yes, 23 times 1 is indeed the same as 23. So it's yes. And what property is it, Michelle? Perfect. Perfect. It's identity. What about the second one? 8 divided by 2 and 2 divided by 8. Are these the same, Rocco?
Yeah.
So Rocco says they're the same.
Wait, what? No.
They're not.
So Lucy, is that true? No, they are not the same. We can't do it with division. What is 8 divided by 2? What is it, Michelle? Perfect. So we got 8 divided by 2 is equal to 4. What about 2 divided by 8? Who can tell me what 2 divided by 8 is, Miles?
A negative number.
It's not a negative number. What is it? What is it, Rocco?
I don't know. I just raised
Don't raise your hand. Elsie. Technically everything's a decimal. What is it, Gore? It is 1/4. We know this because if we look at our division sign, so when we do our division signs, remember, these dots are just placeholders for our number. So the first number goes on top and the second goes on bottom. 2/8, we simplify that to 1/4. Is 1/4 the same as 4? No, it is not. Okay, next problem. 46 plus 15 and 15 plus 46. Are these the same? Thumbs up if they're the same. I'm seeing hesitant. Yes, they are the same because we just switched the order. What property tells us that we can switch the order, Daniel? Yes. I'm not going to write it all out because it's right there. Last one. 13 times 1 and 1. Are these two the same? No. They are not the same. Excellent. So we're going to look at this next problem. So, Anita's mother hosted a party. Is there any pertinent information in that first sentence? No, we have no information. It doesn't matter. The table shows the cost. The only information that we need to care about is the fact that they're telling us it's right there. Use the associative property to write 2 equivalent expressions that could be used to find the total cost. So I want you guys to write 2 equations, 2 expressions to find the total cost. So Adriana asked, okay, so are we multiplying? What word tells us if we're multiplying or adding? What word here tells us if we're multiplying or adding? Miles. Total. That is the key word. And what does total indicate that we're doing, Michelle? It's addition. So it's indicating we're doing addition. Rafi, give me the first expression. Give me the first one that you have. Romario, give me your first expression. Lily, give me an example of this expression. Rocco, what is the expression? Give me one. 24 plus 12 plus 6. But is that it? What do I have to do, Michelle? Sure, I'll put parentheses around the 24 and 12. Whoop, whoop. That works.
Yeah.
What's our second expression, Rafi?
24 plus 6 plus 12.
Excellent. Now, what do I do here? Do I have to leave it like that? No, I have to do something, Adriana.
Put parentheses around the 25 and 6.
Yeah, sure. Here's the thing. We could write this so many different ways. The difference is that we just have to put parentheses around different numbers. We could have put the parentheses around 6 and 12 for this problem. We could put it around any sort of thing. It doesn't matter as long as in the parentheses they are different because we're still going to get the same answer. These two are equivalent. Let's look at this next problem and we'll see if there's pertinent information. Ella sold 37 necklaces for $20 each at the craft fair. What's our first piece of relevant information, Romario? Perfect. So we need to know that she sold 37 necklaces for $20 each. Next sentence. She is going to donate half of the money she earned to charity. Do we have any other important words here, Malia? We have half. Again, then use the cumulative property to mentally find out how much money she will donate. So here's what we know. We need to use the commutative property. Yeah, I said that one right this time, kind of. To mentally find out how much money she will donate. So, exactly. When we're doing the cumulative property, not saying it right, I'm not bothering. Who can give me an expression that we use to follow the property? I want to see a new hand. So Oswaldo got this answer. He says 37 times 20 divided by 2. Is this correct?
Yeah, but
Yeah, it is correct. It's completely correct. How did we know we were going to be multiplying 37 and 20? How did we know, Rafi?
Because
It says each. Exactly. When it says each, that's either multiplication or repeated addition. And I don't feel like adding 37 times. So, we follow Pemdas, which means that because there's multiplication division, we just go left to right. Now, 37 times 20. What is 37 times 20? So, this is $740 divided by 2. What is $740 divided by 2? What is our end answer? What do I get, Romario? What do we get as our answer? Perfect. We get 370, which is half. So she's going to donate $370 to charity. Go, Ella. So if we're looking at this problem, rewrite without parentheses and simplify. When I ask you to simplify, what am I asking you to do? When I ask you to simplify, what am I asking you to do, Nathan? Like terms. So we combine the like terms. So this problem should go pretty fast. I want you guys to do this. So Liam, what is the answer? Yeah, so it's 120y. Once again, we could write it as 120 times y, 120 with y there. Now, when we write it, we tend to put the variable at the end. It just looks neater that way. It looks cleaner. So even though we could write y 120, doesn't that just look a little bit weird? It kind of looks a little bit wrong. So our answer is literally 120y. All we did was we multiplied our like terms and then we had the y we multiplied. What about this next one, Alinza? What did you get for the next one? So Alinza, what's the answer to number 2? 15 plus m. And how did you do that, Alinza? You combined like terms. Which two here are the like terms? The 6 and the plus 9. Exactly. We add those together to get our 15. Does m have a like term here? No. So we can't do it. We just add that m. Once again, a lot of you are so hesitant to leave things with variables. In math, we don't always get a numerical answer unless we're told what the variable means. Unless we're given what the variable means, we will not know what that variable is. However, they might give it to you like this. They might say 15 plus m equals 20. In this case, what would m be? 5. In this one problem, we'd say 120y is equal to 240. In this case, what is y?
120. Or it could be 2.
What is, if I have 120y equals 240, what is my answer, Lucy? Y is 2. So we can either be told what the answer to the problem is or what the variable is, and that's how you'd solve. So here, I want you to factor by pulling out the GCF and leave what is left in parentheses. So Oswaldo, for the lifeline, what is the greatest common factor between 27 and 18? It is 9. If we split this up, we add 27, it'd be 127. We don't have 2. It would be 3 and 9. Do we have a 4? 5, 6, 7, 8? Nope, then we are back to our 9. These are the only factors. For 18, we have 1 and 18. We have 2 and 9. We have 3 and 6. The biggest one they have in common is this 9. So these numbers directly correlate with this. This is what's important and why we want to factor. If I wrote this out, I'm going to pull out that 9, the number they both have in common. And in parentheses, I'm going to leave the matching, the corresponding number. What's the corresponding number for the GCF of 27? What is it, Miles?
3.
Yeah, so it's going to be 3x. We're adding, so it's a plus. What's the corresponding number for the 9 in 18? Michelle? 2. So we'd have it be 2y. Now, you could also write it a different way, but I do not like this way. You could have written it 9 times 3x plus 9 times 2y, but I don't like the look of this one. I would prefer it if you guys wrote it like that. I would prefer it if you guys wrote it like that. Carmen, what are we doing with this problem?
We're going to be adding.
We're going to be adding, but how do we know what we're going to add? We're doing something special when we add these. We're going to be doing something special when we add these. Fernando? Yeah, we're combining like terms. So solve these by combining the like terms and you'll get an expression. For this first problem, what are the like terms? Who can tell me which are the like terms? Hannah?
3x, 6x, and 2x.
Yeah. How'd you know that these were like terms? Who can tell me how Hannah knew? Rocco? They all have that x. That's the important part. So what we do is we combine them, which is called adding. Typically, we might be multiplying, but it's typically adding. So let's look. It's actually only adding when we combine like terms. So what do we get as our answer when we combine these like terms? What do I get, Oswaldo? We get 11x. Does everyone agree? Yeah. What about this second problem? Give me one set of like terms. Give me one set of like terms. Ben?
13x and 13. I mean 3x and 13.
3x and 13x. But what about that 3? 3x has it, and there's a 3. So there's 3x and there's 3. Why aren't those like terms? They both have that 3 in them. Why aren't they, Lucy? Exactly. It does not have the same variable. Those parts need to match. So let's start there. What's 3x plus 13x? 3x plus 13x. Melanie. So Melanie's correct. It is 16x. Okay. Tell me my next pair of like terms. Who can tell me my next pair of like terms? Daniel. There are no more. So we've got an 8y that we've got there. And then we have a 3 here. So since we can't combine those, it literally becomes 16x plus 8y minus 3. That looks like just a 3, but minus 3. So that's our like terms. Like I said, you can only combine it. Last one. What am I doing here? It's touching the parentheses. So what operation am I doing here? What operation am I doing when it's touching the parentheses, Oleg? Yes, I multiply by what's inside the parentheses. So we follow Pemdas. Parentheses comes first. Can I do anything in the parentheses? No, I can't. I can't combine like terms. So now we go on to exponent. Is there exponent? No, so we don't do that. Now we go on to multiplication division. How do I multiply this? What am I going to multiply 9 by? Tell me what I'm going to multiply 9 by. What am I going to multiply it by, Romario? He says either 0 or x. He's partially correct. What am I going to multiply it by, Anita? So I'm going to multiply it by x. Is that it? So, and the minus 1. I have to multiply it times everything in the parentheses. What is 9 times x? Raise your hand for 9 times x, Rafi. 9x. What is 9 times negative 1? What's 9 times negative 1, Tobias? Miles, what is it? That's subtraction. We're multiplying. What is it, Lucy? Negative 9. We are multiplying everything in that parentheses. So like I said, we have this 9. It has to be distributed equally between that parentheses. Pretend the parentheses are kids. Your parents distribute it equally, so they multiply it to both equally. Now, I want you to solve these problems if x equals 2 and y equals 3. Solve them if x equals 2 and y equals 3. First one, 11x. If x equals 2, what is our answer for 11x if x equals 2? Alinza. Perfect, it's 22. Next problem, what is 16 times 2? What's 16 times 2? Lily. It's 32. Then plus 8y, and y is 3. What is 8y? What's 8 times 3 then? 8 times 3. Carmen.
8 times 3 is 20.
Perfect, it's 24. And then we have minus 3. So what would our answer be? 32 plus 24 minus 3. Who can tell me that answer? Rocco.
53.
It is 53. Exactly.
Yay.
Now the last one. 9x minus 9. If x is 2, what is 9 times 2? Daniel, what is 9 times 2? We get 18. What's 18 minus 9? What is it, Rocco? 9. So that's our answer. So let's look at this problem. Let's look at this and we're going to highlight the key words. We're going to highlight the key words. A fall candle gift set has 4 vanilla candles and 6 pumpkin spice candles. What's the important information here? What is the important information, Lucy? 4 vanilla candles. And what's the other important piece, Miles?
There are 6 pumpkin spice.
6 pumpkin spice. Then it tells us to use V to represent the vanilla and P to represent pumpkin. So we're going to write an expression that represents the total cost of 4 sets. So what's the cost of 1 set? What would the cost of 1 set be? We have 4 vanilla candles. I'm going to pick a different color. We have 4 vanilla candles, and V is the cost. So it's going to be V. Then we have plus 6 for the cost is P. But we want 4 sets. That's only 1 set. If we want 4 sets, how do I get 4 sets, Hannah? Multiply by 4. And that is our answer. Thank you guys for coming to my TED Talk.